In this video, we'll talk about the topic that I'm kind of very excited about, but low key very excited. How about this? It's automated acceptance tests. Why am I excited and why is it actually low key? Low key because a lot of people overlook automated acceptance tests and they think about it as some dreadful thing that you have to do um, when developing software products, but in reality, it can be exciting when done right. So it wasn't always exciting for me. I had to go through troubles of figuring out what is actually a good test. And there was like a lot of philosophical questions and transformations for me, and realization that it can actually be exciting. So what is automated acceptance tests? I'll explain with my own words, because if you start looking in the internet, there's just like a whole bunch of different definitions and explanations. So it's a way of testing software to make sure that it meets the business expectations and business requirements that are defined by product managers. Why do you need to have one? Because this way you can guarantee that every change you make is verified and is good to go, so you wouldn't break the expectation of your users that something is not working or something is wrong. But previously you would go through manual acceptance testing, where a QA engineer would just go and manually verify that something is working as expected. But like the automated acceptance tests obviously is about automating that. Okay, so now let's take a look on the screen and talk about automated acceptance testing strategy. Obviously, the goal is to be able to deploy apps at least once a day with fully automated release cycle. I mean, there is a time component here in this goal. It says once a day, but if you remove once a day, it's still valid, right? Be able to deploy apps with fully automated release cycle. You could deploy many times a day, you could deploy weekly if nothing is changing in your system. The point is to have automated verification that any change that is going out is actually a valid and doesn't break the build, doesn't break the expectations of your users. I started with this schema for you to visually see how I look at it, but it wasn't actually how I started developing those tests. So let's just look for Playwright example of the tests. I'm using Playwright as the browser automation library, and because they have documentation on writing tests, but in reality, I've tried many different frameworks over years, and all of them have a super simple use case to get started, and all of them have the same flaw, which is you write your tests that are dependent on the framework and is very hard to maintain, right? So this is why I said low-key excited about this topic, because when this set of like these kind of tests grow over time, it is like super freaking hard to support it and maintain. And especially when the QA engineers rotate in a team, your system under test change, for example, the element locators, like, it's just so many different things. The user flow changed. So I've been constantly looking for ways to change that. And how can we actually write tests that don't suck? That was, my kind of goal. A few years ago, I discovered Dave Farley and his work on test-driven development and acceptance tests, and that inspired me big time in terms of like what I was looking for and how to do things the right way, so to speak. And we're going to talk about it in a little bit, and I'm going to share what I'm doing and how I look at things, right? So I kind of develop from there. But if you want to go to source, it's an absolute must, and like a super interesting guy and the way he explains things. So go check it out. So that wasn't an easy transformation for me, as I learned to look at these tests from a different angle. Like, it's so you should look at it as if you are writing an application that is testing another application, right? So what I mean by that is that you still apply all of those engineering principles to your testing framework, to your testing repository, as if you were writing just regular software application. It is not an afterthought. You have to think about those tests when you're writing your software. What are the ways to intervene into the system to write efficient and fast tests that is easy to maintain? And we will talk about this right now. And then from the recent developments in AI and LLM, now you're obviously thinking, oh, that would be like so much cooler if we could automate writing those tests, right? So how can you develop your testing framework in such a way that AI can write those test cases for you? On this screen, you can see a few things going on, right? Basically, think of it as layers. So first layer is test cases. Test cases is what you write as a QA engineer to validate a certain scenario. So in this case, it is add to cart scenario. You create a user, then you create a cart for a user, you add a product to the cart to add, SKU, and then you confirm cart has one cart item. So this is a little bit simplified, but you'll see why in the next section. Now, the next big thing is DSL. So what is DSL? DSL is how we write those test cases. So you could see that in my test case here, I was using like a plain, easy to understand language that speaks the language of the business and language of the customer. This is super, super important because it eliminates confusion, right? So the team between product and engineering is totally aligned because we receive requirements in English, we write test cases in English, and then we just transform them into DSL, into code where every function is still named in English. So I will show you the code examples. Hopefully it will make more sense. It always helps when you see real examples. And then there's also the comment here that with this dashed line or dotted line about customer perspective. So the test cases and DSL are written from customer perspective using the language of the customer. So the next layer down is more of a like infrastructure in quotes. These are adapters. And adapters could be things like your browser library for writing tests, like Playwright. Adapter can be your API client, literally just an HTTP client that makes calls to a specific API. And then the system under test, which is basically a deployable unit that you are verifying. And these things inside this dotted line, these are written from team perspective. So for example, an adapter that makes a call to create a cart can be named create cart, which is in this case, it kind of matches with DSL, right? But then the idea is that the adapters are very wide and include so many other things that are not included by DSL or in fact hidden by DSL. And you can get like really specific technically here. The goal is that the people that work on these tests, they understand what is going on because these are written from team perspective, as underlined here. And then the system under test really is just your application that you're testing. It could be a mobile app, it could be a backend API, it could be a front-end app. So what's exciting for me here is that this testing approach, this testing strategy equally applies to both front-end and backend. And I've done it successfully for both front-end and backend, and I want to include these examples in the video so you can actually see how beautiful it is. Let's talk about why and how to select, what's the scope of testing basically, how to select where do we draw the line of what we are testing. So this is an example of front-end acceptance tests. You can see that the dotted red line is basically your entire system end-to-end. So think of it as the fully working production application. If you go to the website, you will, I'm oversimplifying here, but for a reason. You will get a front end, you will get a load balancer, and the backend API. So it's just different types of testing that can be applied here. So basically, we draw boundary of acceptance tests for a front-end client around that front-end application. So if your front-end app is a single deployable, you really have like a couple of choices. You can write acceptance tests and stub out all of the network interactions at the test framework level, right? Or you could verify your end-to-end system with automated acceptance tests, including backend. It's just two different ways of doing things. Both are valid, in my opinion, depending on your use case. It is one of those things I'm always answering, it depends. So it really depends on what you're trying to do and picking the right approach, picking the right tool. So I mentioned mocks there, right? And network stubs. Let's talk about test reliability and what it means. So on this simple diagram, I'm trying to show that your ability to manage state, and state in this case, the API response, drives your test reliability, right? So for example, there are two dots on this diagram. On the first dot, you have ability to manage state is lower than in the second dot, and that means your test reliability is also lower because you cannot control the data that your front-end application receives or your system under test receives. For example, this is a great case for third-party APIs. Like imagine you are testing a payment system and there is a Braintree vendor integration. You can't just run a full set of automated acceptance tests against live Braintree APIs because it could be just too much, right? What happens under each specific response? Are we declining cards for what reasons? Like anyone who worked with payment providers, they know there's like pages of possible decline codes and reasons, and you cannot expect to test all of that on a live provider. So instead, you could just mock out those responses based on the documentation or framework and test your side of software and not a third-party vendor. And of course, you can still run against their non-production or sandbox environment, like a set of happy path scenarios every once in a while, maybe once a day or whatever, just to make sure the contract didn't change. But I mean, in my experience, it is, never an issue because of just like how different engineering practices evolved over time. And I don't know, for years, I haven't seen any issues with that. And on this diagram, you can also see two examples. So one is you're testing against live remote environment, and then you're clearly defining boundaries for external dependencies and mocking the dependencies out. Another example here is how to write automated acceptance tests for an API. I'll be honest, I was super skeptical of this because I've never seen it done well before. But after discovering the work of Dave Farley, that just inspired me big time. And let me just talk about it, right? So the idea is that we'll set up API testing framework with Jest and TypeScript and Mountbank. Mountbank is a mocking tool for, again, for network stubs. And then your scope of testing actually is an independently deployable component, right? So if you have a microservice that is deployed independently, that's your scope of testing. If you have a monolith system, That's your scope of testing. And then when those microservices or monoliths interact with other parts of the application via API, you don't want to be testing that. You should be testing that separately as part of that application. So the idea here is to mock and stub out those requests so that you can control the state and the environment where this is executed. So let's take a look at this test case. It is for personal cards for deleting items. So the first step is to create a card, then add an item to a card with a specific search query. This is the DSL layer. Then you want to add second item to the cart, and then you're viewing cart, right? So as a user, you've searched for an item, you've added it to the cart, and then you're clicking the cart icon and going to view the cart. And then what you expect to see there is that your cart has two items, and when you remove one item at a specific index, I say first or second item, you expect the cart item quantity to be 1. So a pretty straightforward test, but it illustrates that this test case, if I just copy and paste it and send it to a non-technical person, they will be able to tell me what are we testing here? What are we doing, right? Because it's go to cart, add to cart second time, view cart, and then remove one of the items, and then confirm that you only have one. And this is what I mentioned earlier, customer perspective, right? So we just looked at the test case. So these functions, these are DSL, and yeah, that's your test case. But if we go inside add to cart, you will see, oh, this is actually quite a big function. And this is your adapter, and it's written from the team perspective. These are the functions that are written by developers and QA engineers that interact with something on the page. It accounts for search queries, for adding items as a subscription, for adding items with sale or without sale. Think of it as the defined way to interact with a system from a team perspective. But as soon as you write that function and it's working, you can see also it takes into account if the add to cart button is active or not. It will fail the expectation if it's not. Things like that. And this is the place where we have defined selectors for those elements on the page. And you would use that, as I said, you would work on the function and write it once, but you will use it throughout all of your test cases where you are adding items to the cart. So yeah, that basically it. You can see here it was an example from the Playwright adapter in my schema. And system under test, in this case, it is just a URL. It is a running website that you can point your testing framework to, and it will open the testing environment, staging, or production, depending on the configuration. One of the common questions that I think about is whether this automated acceptance test should live within the application that you're developing or as a separate repository. The answer is actually like super simple if you think about it. If you want to optimize for simplicity and ease of development, you want your tests to live together in the same repository where the application is, for one simple reason, for versioning, right? So let's say you've changed your API or you've added another endpoint or you removed something. As part of this, you also want to update your test suite. And if it lives in a separate repository, then you somehow will need to tell it if something is up to date or a specific version for running, because you could end up in a situation where your deployable unit, your application, is of the newer version, but the test it's running against of the older, and then it will be like various failures and stuff like that. Okay, so let's move to talk about the specifications for backend API. It works the same exact way. You have 4 layers from the test case in DSL from customer perspective, and adapter and system under test from the team perspective. Again, system under test in this case is a backend API with database, which is, again, it's a state, right? So database is a state. So ideally, you'd want to control that somehow. We'll talk about it. And then you have adapters. Adapters in this case are just ways to call APIs. So in this case, you can see my adapter to call API is called create cart. In here, we're actually building the request, and then building the URL for making a call, and building the body of the request. So what it is that we are sending as part of the request. So in this case, it is add SKU to cart. And this is actually a great example of using the customer language versus the team language, because add SKU to cart is very like business centric and very team centric. But for a customer, it is add item to a cart, right? So we kind of like hide in the implementation detail behind the naming of the function, which when you do that separation between customer perspective and team perspective, it is day and night. It's just so easy to work with. Cool. So this is an example of add SKU to cart adapter. Again, we have the URL here, the body, the headers of the requests, and then the body of the requests, which is, your order ID, your SKU ID, the quantity, and so on and so forth. Now, we've talked about adapters. Now let's talk about the DSL. So for that, we have a folder called interface, where it's split in 2 areas. So this is a very big application, very big API surface here. So we did split within the team. We decided to split the interface into 2 categories. One is related to actions, and the other one is related to expects. So expects is a way to validate the result in Jest and TypeScript. So for example, here we have an interface for add SKU to cart. So yeah, I just show you, like, I feel like a lot of stuff, maybe even too much. But this is all about automated acceptance tests I wanted to say. It's just such a topic I can talk about for days, and like honestly, it kind of grew on me in recent years, purely because I discovered this way of writing those tests. It's not painful anymore. They are reliable, they're fast, they're easy to write, but it took a lot of work up front to think about it. And the other beautiful thing is that this is easy to extend with AI, because you could literally write a test case in English and ask LLM to use your existing interface functions to develop that test case. And if the interface functions, they don't exist, then suggest an adapter function, and so on and so on. It's just straightforward, right? And that is like easy to automate. So one thing that we didn't talk about, which is test isolation. But I feel like that could be another 10 minutes, and a topic for another video. Let me know what you think about this one, and if I should dive deeper on this topic of automated acceptance tests, and if we actually even need to write some together for, we just pick a website on the internet and write some tests for that.